Okay. So what we are going to solve is we are going to solve this problem, and in this problem we will specifically look into largest common subsequence. And once we are done with an algorithm to find subsequence, we will then move to longest common substring. So, but before that, uh, let us discuss this approach here. And it is quite intuitive that if you go on checking the combinations of all the approach to solve these algorithms, and if you apply a brute force approach to solve this, it will always lead to exponential form of complexity. So brute force approach, like I mean, here you try all possible combinations by putting index at 1, 2. You'll check all the combinations, and then you arrive at longest common subsequence. Its complexity is generally in exponential order. So it depends upon what exact code you write, but usually it is 2 to the power of n. And we generally we don't want such kind of approaches. So what we do is we prefer dynamic programming based approach. We will write that approach and then we'll see what exactly the complexity of that approach would be. But the complexity which we get from dynamic programming would be far better than this brute force exponential complexity. So let us start with that approach. Now we will basically solve this with recursive approach first. Okay, so let me minimize and let me make a space for me to draw a recursion tree. So we will consider the same exact example, the one which right now we have highlighted. Okay, so what we do is we rely on recursion. Remember, whenever we want to work on dynamic programming, generally a dynamic programming can be fit into a small three-step process, especially when we talk about recursive logic. The first thing is identify this subproblem, identify that subproblem. Then the second thing is you have to find how to reduce the larger problem into subproblems. And at the same time, when I'm looking for, there is always here uh, in dynamic programming we always do something called as choice. We make a choice like either this or that, either this or that, max of this, min of this, some kind of choice. So what is that logic choice? And some people also call it as what choice diagram, or some call it as logic of choice or choice flow, something. I'll just call the choice you need to make from that subproblems and that. And then four, you should have some logic to merge these solutions of subproblems. Then that should give you the result of entire problem. And if it is specifically a recursion, you need to find out what is base case. And generally the base case is smallest possible subproblem at which we stop. If it is if you are going for a recursive approach. So generally we go it for recursive approach. And we always start with recursive and then we move to tabulation. If we directly jump to tabulation, uh, the logic might not be that intuitive. So generally, if you are working on a very new problem which you have not yet solved, or you do not find any such previously solved problem which is of similar pattern, then the best approach would be to solve it recursively and then figure out the tabulation method. But if you already know that problem, you know it is somehow the twisted pattern of some other already predefined solved problem, then you can directly solve with the tabulation method. So accordingly, what we will do is we will try to solve. So first we will solve with the recursive problem. So what we do is, this is a larger problem. We start breaking it into a smallest problem where I can decide the largest or the longest common subsequence which I can find. So what I do is I go for a recursive approach. So what I do is I'll consider the two strings. So what's the first string? We take this ABC. Uh, this is the string, and this two will be the string, the first thing. Let me make everything. Okay, so I have this two strings. Now, if I want to find longest common subsequence, these are the two larger problems. I want to break it into a smaller problems so that I can easily solve what's the common sequence between these two one. So when I want to break this problem into sub size, what I do is I keep on removing characters from reducing the size of this two strings, so that I end up with a set of characters in string with each one character and one character. So if I only have one character and one character, you can decide the sequence. Or if you have a string with zero characters, you can always decide that whether the longest common substring, the value of longest common substring. If I consider two strings with length 0, what will be the length of longest common substring? Will be 0. Okay. If I have two strings with length 1 and you want to find out what is the longest common subsequence, what you need to do? You need to just compare those two characters. Then if you compare the two characters and if you find both are the same, the longest length of longest common subsequence will be 1. When string 1 and string 2 will only contain one character each. Now second characters, if the string 1 and string 2 contain two characters each, it depends upon the solution which you have obtained when the string had only one character each. So based on that, you will now add the compare result of comparison of two second characters of the both the strings, str1 and str2. So that's how we keep on increasing that. So what we do is we start splitting this into two sub problems. So if I want to split this into two sub problems, what I do here, see there are two possibilities. Now what we do is we start solving this from the reverse end of that. If you want, we can also solve it from forward end, but since this is a recursive approach, it would be more intuitive if we start solving from the end of that strings. So what I mean to say is that now see, when I have two strings and you want to find longest common subsequence, then here, if I want to break this problem into sub problems, what I do is breaking this into sub problem means I need to remove this character. I need to keep on removing these characters so that I only end up with one A, or I only end up with one character in this one. So at the end, I keep on merging it from the bottom end of recursion tree. So when I start merging them from the bottom end of recursion tree, I would now keep track of the subsequence which I keep on getting that. Okay. So I want a sub problem of that. So when I want to say sub problem, see either I can remove this Z, I remove this Z and compare this entire string str1 with the newly formed str2 with last character removed. This is one case. The second one retains str2 in full and remove one character from this the first str1. So there are two possibilities. So I can get longest subsequence from that one transformation from left side and one right side. So whichever is larger subsequence which I get from left branch or right branch, that will be the part of entire problem here. So when I keep on coming back to the top of recursion tree, when I keep on coming out of recursion chain. So what we'll do is this has two problems to solve. This is one and another is this. So here what we do is, let us do one thing. The first strings left character is removed. Here right strings, left character is removed. Okay, so I need to check longest common substring between these two. So now let me solve this entire left subsequence and then we'll come to that. So now this will have two more combinations. What it is? First remove the left and right side, remove the right character. Okay, so then this has two possible substrings, two possible subsequences. So remove left and remove right. So here you have removed left and here you have removed retain this entire character and remove this. Then you get, so here each starts getting uh, characters keep on removing. So when you, I think we have taken a too big string. This might not fit into the screen. Okay. This will have a very huge branch of this trees. Let us do one thing. I'll reduce the string length so that we can find. Okay, we'll just keep this small AFGR and AFRG so that I see why we are doing this, because I want to fit that into recursion tree. This is first string and second string is AFRZ. Let me reduce the size of this as well. Okay, so when I have two sub problems with equal length strings, what are the two sub problems I'll be getting? Okay, this will be the two substrings. What I said, initially we will remove one character from left and we will retain right as it is. Then what we'll do is we will retain left and we will remove one character from the right string. So we will find longest common subsequence among these two strings and among these two strings. Whichever is larger among these two, that would be the length of longest subsequence at this point, right? So now see here when I say why I'm removing one character and why I'm removing right side, this is a way to reduce the problem size. Once we solve this recursion tree, we will see a pattern where you will now understand why we are removing one character, one pattern from left and one from the right. So let me first have this entire recursion tree plotted. Then we will understand how exactly the algorithm works. So now when we want to solve this left sub problem, it has two cases. So what is the two cases? Okay, what will the two cases? What is the first thing I said? Remove one character from left and retain right as it is, or retain left and remove one character from right side. Now this will have two more combinations. Okay, this will have two more. Two more combinations. What I said? Remove one character from left, and right would be remove one character from right. then this will have two problems. Okay, what I said, remove one from left and remove one from right. Okay, so now when you have at this point, still I had to a sub problem to solve. So when I start working on this, the tree which you have to the left, what's the length of the string here? What's the length of the string here? The length of the string one, see, I'm comparing two strings. When string length of one string is 0, what is the longest common subsequence? The longest common subsequence at this point will be 0. So this is what is the base case we are talking about, or the smallest problem which we can easily solve. So this is the smallest problem which we can solve. So here the recursion will end because one string is of length 0. If any of the string length is 0, the length of longest common subsequence will be 0. So this recursion here will stop. So once it is done, I go to parent. Now I have a right branch for this to solve. So for this right branch, now I will start further creating a sub problems for it. Okay, so remove left, remove one character from right. So this will stop here. Since the second first string has become uh, null, there will be no further recursive call because there is no possibility of any subsequence here. So I get to back here, then I come to right branch. I still have right branch to solve. So I come to this point. What's the left? Remove one character, and right problem will be, so when I talk about right side of this, remove one character from left. So this stops. When I come back, I come to this point. And when I further solve this, you have this 0. And here you have this as 0. Fine. So this ends at here. So you get 0 here. You get 0 here. Now when you get 0 and 0, you are at this point. When you are at this point, what you have here? How many characters string you have? You have two strings with each with one character. And what are these two characters? These two characters are exactly same. If these two characters are exactly same, then here when I have the two characters with exactly same, now let me in a bracket type the length of longest subsequence. Here I'll get, it will be 0. Here when I type, the length of longest subsequence will be 0. So when I combine these two, I need to take max of this. The max of this is 0, so I come here. So when I come here, what I do is now I check what was the result of this two. Let's see why. Okay. So here the length of two substring is 0 and 0. Now when I go back from this recursion tree back into this, I encounter a problem where I have the two characters here. The two characters here. See, remember, now if you see this sub problem here, here is where our core logic starts appearing. See, I have split into sub problems, and each sub problem might have some what do I say? Might have some of longest common subsequences and all that, right? So now when I have a substring with sub problems to have, here this could be some different value, here it could be some different value. So I take max of this, I take max of this, and when I merge them, I have two characters here, A and A, and these are exactly same. So when I exactly had A and A, then I have a match for one subsequence. So now the length of my subsequence is 1. When I have two characters exactly matching, and the two characters are only 1 and 1. So now when I have 1 and 1, the length of max subsequence here will be 1, right? So here, what is the length of subsequence at this point? Since the second is 0, what I get here as 0. So when I merge this 0 and 1, what I take here? I always take, what I take? I always take max of this both subchilds. What it is? 1. So now I'm starting to going back to the recursion tree. So I get 1. Fine. Are you getting this? Okay. So here, since this left is first is null, the length of common subsequence will be 0. And now when you combine this both, now see this how it works. So here when you are at A and F, now the max has arrived from the bottom strings. Now what you need to do is you have this additional characters. So here if you see, you can say that it is 1, but I have A and F, so here it is 0. And now when I combine this two here, what I get is the max as 1, and here it is 0. Here it is still 0 because the first string is null. So now when I combine this both, here it will be 1. Here it will be still 1. Okay. So when I have this as 1, then I reach to this tree here. Then I jump to right, and now I need to solve the right subtree pattern. So let me solve the right subtree pattern, and before that I'll just connect this with arrows so that I can place the left sub problem properly. Let me connect them so that I can move the trees to the left so that I can make space for this problem. No. Okay, I think these are the childs of this nodes. After that, what I've done, okay, remove left and one from right. How? I think what we have done here. Okay, so this was 0, we stopped it. Then this was expansion of this. Okay, this was 0. We worked on expansion of this node. Okay, so now when, okay, we have reached to a point where I need to now solve this right subtree, right? So we have solved, we have been retaining this length max of max, and we have retained that. So here you can see that at this point of time when I have these two strings, the length of common subsequence is 1 because common characters are A. Now I need to solve to this node. This is unsolved. So what I said, this gets split into two problems, left and right. What happens to the left? Remove one character from left, and when on the right side, remove right character of right string. Okay. Now this has two more problems. This is one, and this is one. Here, remove one character from this, and remove one character from right. So this chain stops at this point. So we'll only solve this particular recursion tree. The rest logic will be quite more clear to you. So this is this string and this will be this string. So now let me take it. Let me make few more gap to this nodes. Okay, so I'm just trying to solve them at proper level. So if you understand this pattern, I think we can directly start coding there. Okay, so we have split to this point, and so since it is null, it will not no longer work from there. So now it will work here. So this is one problem to be solved. So what happens here? I get two more nodes to it. So this will be 0 and this will be this. And I'll deliberately, okay, let me also take it so that so this will have, okay, so we have the exact same string, exact same call. So we'll have 0 here, then this will make this two calls, and this made this two calls. So what happens here is it is 0 and 0, and when you say 0 and 0, the max, plus here these two strings are exactly same, so one character, both are having one character, and both characters are matching, so the length of substring there will be 1. So here it will be 0, and max of this both, what will the max of this both? 1. And what is here? 0, because one string is null. So you take max of this. What is the max of this both? 1, right? So now what's remaining is this sub problem I need to solve. So this has two more sub nodes. And so remove one character from left, remove one from right. So now when you solve this, how do you, I hope this will have two more. So do we have any AF? AF, AF. If you see here, you will understand what exactly I'm trying to solve. So this will have two. So this node and this will have two more subnodes. We took, so remove one from left and remove one from right. So this will be 0. I'll not solve it further because you already know what would be the result of this, right? So this will be 0. This AA will exactly give the same tree like this node, right? So whatever you see here, the result of this node will be exactly same as here. So this will be exactly same. So I'll not solve, I'll just note down the value for this one. So this will be 0 here. This will be 0. Now when you take max of this, here you will get max of this both as 1 when you're merging this. Now we have this problem. Let us see how what happens to this problem here. So when I solve this problem, it has two more sub problems. Here is where something, so what I said, remove one character from left, and here remove one character from right. This is what we were talking about. So when I say, when you remove one character from right, what will be the string length? 0, because here str2 is null. So whatever could be the length of a string, the longest substring will be 0. Now here, if you solve this, we are exactly solving a similar problem. So I'll just highlight that, and I'll not further divide that into further diagram. So I am assuming that I am plotting tree similar to this. So that's why I just colored as a green colored node. So now I have two nodes to this. Okay. So now when you solve, what will be the max here you get here? Left and right, whatever the max length you get from left and right, I get 1, right? Okay. So now when you want to combine, let us understand what is different here at this node. We need to understand this logic. So at this node, see, technically speaking, at this node, technically speaking, what you are looking at, technically speaking, here you are looking at two strings which have two characters each, and both the characters are same. So expected length of longest common subsequence at this subproblem stage, what should be the length? It should be 2. Now, till now, what I have been taking, I have been always taking the max of left subtree and right subtree, right? So now let us figure out what should I do here. If I do max of left subtree and right subtree, if I go by my discussion logic, I'll be getting 1. But obviously getting 1 is a wrong answer for it, because here the length has to be 2. So what happens? Let us check that. So whenever you are merging these two, what you need to do is you need to check the characters at this 2 1. If these two characters here, if the two last ending characters, if they are same, it means that I am getting one additional character in my sequence. So I can increase the length of my sequence by 1, because the last characters of these two strings increase. So if the length of substring increases by 1, because here the last two characters are matching. Remember, so when you're going from bottom to top, your string is increasing from 0 to 2 characters, then 3 characters, then 4, 5, and then it ends at this one. So literally it is like you are starting from 0th characters and you're scanning till the end. So this is like starting from the 0th character, then second character, then you will find here third character. So at this level you will be dealing with third, fourth, and characters. So at any point of time, before you are deciding max of left subtree and right subtree, what you need to do is you need to check what are the last characters of these two substrings for which you are finding the subsequence. If the last two characters are same, if the last two characters are same, it adds one to the subsequence. So you can definitely take that two characters are matching, you can definitely add one. Now this one will be added to what? This will be added to the substrings which will be formed by the remaining characters of these two strings. So if I want to know if I want to know the subsequence formed from the remaining characters of these two strings, what happens? It will be always to the left and it will to be always to the right. So these two characters have matched. These two characters have matched at this point. So it would be sum of, it would be 1 plus it here. If two characters are same, it would be 1 plus the previous length of longest common subsequence. From where would you get the previous length of longest common subsequence? From your left and from your right. Now, when you want to take your length of previous longest subsequence, you have two possibilities. You could get a better longer common subsequence either from a left or either from the right. So what you do is at these stages, when you have such stage wherein the characters match, what you do is you check. If the characters match, then it would be 1 plus LCS from previous problem. Okay, this I can do here. If the two characters match, then it will be 1. Why it is 1? Because I have additionally matched two characters here when you are working for this sub problem. And when you say LCS from previous problem, so what do you mean by previous problem then? These are the previous problems. So when I say LCS from previous problem, you will be calling longest common substring for the previous problems. Okay. So 1 plus the 1 plus the longest length of longest common subsequence from this remaining string. So here what is the remaining string? A and A. So you will be calling longest common substring for A and A. So this would be 1. So 1 plus 1 will be 2. Are you getting? It would be 1 plus 1 and the matched characters 1. Okay. So let me take your responses in chat. Have you understood what I'm trying to do here? Can you respond in chat? Are you getting why I am adding this? So why you need to compare the last characters? So technically speaking, every time you're merging, you need to check the last character. So if the last characters is same, if last characters from both the strings is same, then you add 1. 1 plus the longest common subsequence which I get from previous problem. So from the previous problem, whatever I get, to that I'll add 1 because now I find one character which matches in the both the strings. So I can add it in the sequence. Can you respond in chat? Have you understood the logic to this point? This yellow colored block when I'm trying to solve them through a recursion. Can you type? Can you type in chat window? Or you want me to explain? I'll explain again. So what we will be technically doing is we always compare the last characters or two strings. If last characters of these two strings they match, what I do is I just increase my counter of longest subsequence by 1. So this 1 will add to the longest subsequence which I get either from the left or right based on the length of the LCS we get from either left or right, whichever is maximum from that. So every time I split, I'll be doing the same. The moment I get last two characters same, I add the length. So I add the length. Then the new sub problem which I'll be getting is remove this both the values from it, remove both the values, and then call it for a the next sub problem. So wherever I have these two characters, last two characters matching, instead of doing it from left one and right one, what I need to do? I need to make a call by removing this two and make a direct call to the removing with the remaining characters. So whatever I get from that plus one, that I'll be adding to this. So when I go on that logic, so when you have this A and A, what I said, when the last characters at any of this sub problem, if they match, what I need to do? 1 plus the LCS which I get, what it is? 1 plus solve the problems by removing these two characters. Whatever the LCS, let us call this function as longest common subsequence. Call it with what strings? By removing these two characters. When I remove these two characters, what is remaining here? Null and null at this stage, if you look at for this problem. When the last characters match, right? Plus LCS null and null. So when you say null and null, what will be the result of when the either of this is 0 and 0? When either of this is 0 and 0, what I get is, let me point out a call. What would be that node? So that node is LCS with two blank strings, comma and comma. That's it. If I have comma and comma, the length will be 0. So whatever the value which you get from this, whatever the value which you get from this will be 1 plus LC of this two. So it is 0 plus 1. So it will be overall 1. So now this nodes will not met. I'll just make them dotted. So you will so I've made them, you can see. So I'll just remove them as dotted, like we don't need this. So instead of these two calls, I need to make this. So here too, when you get these two strings, so wherever in this series, whenever last characters match, then I found one additional character in my sequence. If that's the case, what I need to do? As I said, if that's the case, what I do is it would be uh, let me, if whenever it is this, what I said, it would be 1 plus the sub problem by removing both the characters, the last matching characters. What it would be? A comma A. So this will make a call to this node. In my case, this will make a node this will make node to this call. So to directly make a call to this node. And these will no longer be made. These calls will no longer be made. Okay, so these all will be avoided. Instead that, what I get is I directly get this call. Okay, so whatever the value from which you get, 1 plus this, what is this? I get 1 here, this 0, this 1. So overall, what will be the value which I'll be getting at this substring will be 2. The length here will be 2. Okay. So when you now, if you come back here, now this call is done. So now you have 1 from here and you have 2 from here. Now what's the possibility? Do the last characters match? No. If the last characters do not match, you make this call, right? So you have made this call, but here the last characters match. If the last characters match, means I have one character matching in my sequence. So it would be 1 plus the longest I get from the remaining 2 strings. Remove these 2 characters, whatever the new strings are formed, call this LCS recursive calls with that 2 newly formed strings. So whatever I get max from this, that plus 1 will be the max subsequence at this sub problem level. So from here you get 2, from here you get 1. Here the last characters do not match. If the last characters do not match, you do not have no option. You have to reduce this problem size and make a recursive call. So here when you make a recursive call, then this left subtree is what this goes all here, and here this goes all here. Then what you need to do, you need to take max of that. What will be the max of that? Max of 1 and 2. The max of 1 and 2 is 2. So if I have a subproblem AF and AFR, this is the max. So you get from now. Now you are at this stage. You have completed this call. So 1 here and 2 here. Do the last characters match? F and Z? No, if they do not match, this call happens. This both. So when you have completed this call and when you're coming back here, what will be the max? It would be max of left and right, 1 and 2. What it is? 2. Okay. So now when you go back here, you have right to solve. So to this node, when you keep on solving, do both the characters match? No, they do not match. So you get 2 trace. After that, somewhere you will get this AF once again. You get 2 from that. So this itself, this node itself will create such a big branch like the same thing. So the value from here appears, this would be both 2, and from when you do here, the value appears from 2, here it would be 3, the max and max here it would be 3. So when you're creating a sub problem, what you need to do is you have to check whether the last characters of these two strings match. If they match, means I have one matching sequence. Then you just add 1 and remove this matching characters and solve it for remaining problems. Your problem gets reduced drastically there. Moment you get matching characters, add 1 to your length of your longest subsequence, and whatever the new sub problem which you get by removing both the characters, solve for it. So whatever you get plus 1 will be your new length of longest common subsequence. So what we mean to say is that let me create. So what we are exactly the logic what we are trying to discuss here is, if I have, let's say if I have uh, two strings str1 and str1 and str2. When you say that the longest sequence between str1 and str2 is say is 2. Let's say the longest is 2. So if I append a new character to this, for example, if I do str1 plus a new character called as z, and if I do str2 plus new character z, then what will be the new longest common subsequence? So will you solve it? So will you do this? If I append something, will you do this? Will you call a new LCS with these two strings? When I append a new character to this str2 and str1, you know that the length of longest common subsequence between str1. This is known fact. We have this value. We have this. So when we have this, and when we do this operation, what will be the LC of str1 plus z and str2? So you will not solve for this new string. What you know is this will be equal to the LC of str1 and str2. It will be LC of this plus 1. So why I am doing this plus 1 here? Because I know the new characters which I am appending to this string both are same. So they have to add to the sequence. They will definitely add to the sequence. So this is what pattern I am doing at this point. Whatever the new which you find at this, whenever the last characters are same, I am relying on this fact. I am relying on this fact that if I already have LCS computed for two strings, and if I add a new same character to the end of that, I need not compute LCS once again for a newly formed string. It would be just 1 plus the longest length of sequence which I already have for those two strings. That's what exactly I'm doing that. So assume that this is case 1. Okay. What would be the other case? When I have this case 1, I do this, right? What would be the other case? Here, other case. So the case 2. In the case 2, what we are looking is, what I am trying to do is, let's say here instead of Z, here I add, let's suppose I had two different characters, U and V for the case 2. Okay, for case 2, instead of adding two same characters, I am now adding U and V. If this is the case, and if I know that LC or LCS, I already have this value computed. If I have this, what will be this new LCS of this? What would be the possibility of this? The possibility of this now V. So if I do this, then I have two possibilities. I can get a new LCS. I can get a new LCS by calling this. Okay. So I might get a new LCS if I consider U. You might add a new one, or or this could be this as well. They're two one. So whatever I get max from this, that will be the new LCS. And this is the case which I'm generally doing when my last two characters don't match. Wherever last characters they don't match, I create two this. But if they match, I just create a new problem by just removing this, and this is a new problem. And the same repeats for this problem as well. Had it been this a different problem, you will have the same repetitions for this problem as well. For example, here you will get a different problem. So when you call here, two characters are matching, 1 plus AFG and AF. AFG and AF. So here it just creates a new problem, and we start splitting that and we start solving that. So you will understand here better. Let us suppose if it is equal to, let's say if it is XY and both are XY. So let's say if it is XYU and it is XY. Let us consider the initial values of X and Y. So the longest common substring is 2. Yes, subsequence. See, I might have wrongly be uttering substring. Remember, it is not substring. We are solving it for subsequence. I might have uttered substring. Don't rely on the definition. Okay. So, what is the longest subsequence between str1 and str2? Is 2, right? If I add a new character to this Z and Z, what will the new string then? The new string will be, if I do this to this, the new string will be, if I do this, what will be the new string? The new strings will be XUZ and XYZ. If I add the same characters, are you talking about? So what I'm saying is, here it just increases by 1. I hope you are getting this pattern. I hope you're getting this. But in case 2, when I add U and V, the new string would be XUU. In subsequence, we do not consider same characters. This would be V. Okay. So now you can say that here I have two combinations. str1 with U means XYU with str2. Does it make any difference? So whatever the max I get, or just remove this. So I have two possibilities. Either you include it or you exclude it. When two characters do not match, remove one and check whether this matches, and remove one from other string and check. So we have two possibilities. That's why what we do, we remove one character from left and we create another problem, and another problem would be remove one from right. So both could result one max substring. Okay, so here when you do LCS str plus u and str plus retaining str2 as it is, the earlier one when you're returning str2 as it is, so what you have the same x y u u. So here the string would be x y u u plus u, and this str2 means the original str2 without any adding this one, what it is, xy. So you get max substring from this, or you get a max substring from retain str1 as it is. When I say str1, what it would be, x y u. Now str, here it would be x y v. Okay, so it could be max of any of this, or if you do, this will make a case even more intuitive. If you do this, you will understand. It would be x u v with xy, or x y u. If you do v plus and u, so it would be x. So you can say that when I just ignore this and when I do that, I always can get sequence 3 here. So what I do is I take max of this two, either from this or the one. So this case is when I do when the last characters do not match. If they match, then I create a new problem completely by eliminating that, and I just assume that I am adding the LCS by 1. Okay, so now when you keep on solving this, when you create a big merge tree and when you keep on solving this, the moment you come to this position, you will be having the longest common subsequence. Now, how do I know what is that exact sequence? So wherever you match or whenever you are merging that, you can just put one character in a stack. So wherever you keep on getting a matching characters, just keep on merging that into a stack. So when you get this character, what you do is you can just reverse this stack and you will get an entire sequence. So we will first implement it lengthwise to get all the lengths of these graphs. Initially, we'll write a Python program which will give you the longest length. Then we will convert that to actually print the sequence. So here for this problem, if you solve, the actual sequence would be AFR. Okay. Now, okay. So now tell me, is it clear? Have you understood at this point? Others? Okay. Okay. So I think we have 10 minutes. Let us see if I can write a basic recursive program in 10 minutes. We'll just convert this into a program. Very small program. We'll just print the length. We will not print the sequence in that. We will not even do memoization. Now remember, here you can see the scope for memoization. What is memoization? In recursion, whenever I get a same call, instead of calling it again and again, I need to store the result, and wherever I make another call, I need to retrieve that. Memoization, we will see it later on, but let us implement this program as it is, exactly as it is in a recursive one. It would not be more than 3-4 lines. It will take very short time. It will take. Just let us try, at least make a try. So I'll not take more than 10 minutes. 10 minutes, I'll hard stop. I'm opening my PyCharm. Just give me a few seconds. Yeah. Let me share my PyCharm screen. For ease of use, I will just have this logic in my PyCharm. Let me just switch back to PyCharm window. Okay. We'll close all this and I'll create a new thing. Okay, let me call LCS recursive. Okay, we are fairly implementing only recursive version, and for time being, whatever I have discussed there, I'll just need it as it is. So we will use it for our work. What we need is I need to write a recursive function LCS. What I need to provide them two strings. Let us call it as str1, str2, and I'll just pass the index, right? And if I call the length of string s1 as n, I'll call length of string s2 as m. I'll pass string as it is. So what's the first thing I do? I need to check the base case. What's the base case I do? If length, or what I'll do is, see, remember, let us call this n and m as the length of these two strings, exact length. Okay, if it is 3, we will pass, or we will, let us consider one. Let n and m denote the index of the last character of the string which we are passing that. Let str1 and str2 be as it is. Okay, so when we have n equal to 0, or if m equal to 0, what I do? If any of this is 0, what I do? I return length as 0. So what it is? It's my base case. Okay. If it is not, what's that? It is or in Python. Else, else. What I do first thing? If, see, base case and recursion, we have two cases. First case, what the first case I said? Check if last character of both strings match. If so, how do I check? str1 of last character n equal to str2 of m. If the last characters of this they match, what I do? Return. What I'll be doing? Return 1 plus the new LCS problem for this. What will the new LCS problem? str1, str2. Now the length would be n minus 1, m minus 1. Reduce it. Reduce that length. Getting that? If they do not match, let us suppose if they do not match, reduce the problem and reduce the problem and get max LCS from these sub problems. Right? This is what I'm doing here. So how do I do that? Max of, what I'll do? I'll do return max of. I need to return max of two calls: LCS, str1, str2. Two possibilities. What it is? Reduce left by 1, retain right as it is. Then another call will be LCS, retain left, str1, str2, retain left as it is, and reduce right by 1. I think this should be enough. This should give me the longest string. So whenever it goes match, okay, max, okay, I think it should work. This is the rough simple logic. Now let me print it for LCS. Let's see if it runs. What are my two strings? What were the two strings in my example? My two strings in example were these were the two strings in the example which we have solved. Okay, AFGR and AF. I think we should get answer as 3, right? So AFGR, this is one string. What is the other string? AFRZ. And as I said, now if you see here, I am directly checking and n minus 1. So I think I should pass 1 less than length. I cannot directly pass the length of this. So let me retain this as it is. So what I'll do is I'll call str1, comma, then I'll call str2. Now I cannot directly call length. So if I do length, then I'm increasing index by 1. So what I'll do, I'll pass it minus 1. So minus 1, and this would be minus 1. Okay, and what's the problem with this? Why it is showing unsolved reference? Oh, did I close this bracket properly? The characters are different. This quotes, this encoding is different. Sometimes when you do copy paste, this does happen. Make sure the encoding is there. So this should give me 3. Let's see, we will run what, let's see what will be the output of this. Okay, so I am getting 2. 2. What's the length? So I'm 2 means something I'm messing with this n and m only. Is it right? str1, str2. Okay, I think this length has reduced. I think this might be wrong. No. I think here if I directly pass this n, then I need to check for minus 1 and minus 1. And I'll pass with mu n minus 1 and n minus 1. Okay, so I'm getting this 3. Any complex substring which I have, for example, let's say jkl, and here I'll add x k, and I'll add m n k. So now tell me what's the AFR, J and J are matching, K and K are matching. So what's the length? What would be the largest substring? Common sequence AF R 3, J and K. I think I should get 5 if I solve this. Okay. Am I getting 5? Yes. Okay, so any other test case which you want to test? That's it. It's a simple recursive one. That's it. That's a program, just a simple recursion. But okay, when you look at the entire approach, it might look very complex, but this is the only code. I think uh, fine. So let me bring this slightly. Okay. So you check this. Okay, let me go back to tab lecture. Okay, so now I think this is a program for this. It worked. Okay, this was the exact problem for which your problem was able to solve. So I think now I hope you have understood why it is this, why I have did n minus 1, why it is one reduction in this. See now, imagine had we discussed this problem by keeping code into mind, that would be very counterintuitive to understand the logic. I hope you understood the logic and the program, the recursive program. So what we have done, we have started with the initial one. Remember, your logic didn't start from this. It went down to a smallest problem, minimum problem. Then it started working from there. Okay. So this is called as top-down approach, and when we look it. Now the optimization I want to do is to memoize this. I need to store the values of this redundantly computed values. And if you recall my very earlier program, we were able to generate the recursion tree dynamically. So what we will do is in the next lecture, we will generate a recursion tree for this program dynamically. We'll see how large that recursion tree can get. Then we will memoize, we will see what will be the newly formed recursion tree. And once we look at all this one, what we do is now we will also look at the tabulation method where we will have the table. So we can have a table, and from the table we can directly get without any recursion. Non-recursive solution will also look at non-recursive solution as well. So understood the program? Yeah, As Akash has said, I think even n is equal to minus one will also work. So that I think Akash answer is far more better. What is the change I have done? Instead of that, if I can take Akash solution, that would have been better. That would be more understandable. Because see, what I've done, I've stopped at 0. I hope you're getting what Akash wanted to say. Have you understood what he wanted to say? See, I stopped at written, but if I say if I'm starting with n and m, 0 is valid index for me. So I should have checked n is equal to minus 1 or m is equal to minus 1. That is what I should have checked. But what I have done, I have written this and I am checking n minus 1 and minus 1. It's up to anything. But I like the Akash one. The minus 1 is more understandable. This makes even far more confusing. Minus 1 and minus 1. I think I'll do that. Let me just do it. Or you can try on your own. Okay, I think I've already taken much more time. I think okay. So can I get a final yes? No. Have you understood this? The program, the approach. Okay. So I'll share the program. Okay. Fine. So in next lecture, we will convert this into memoization, and we will also take the tabulation method as well. And I have recorded this entire session. I'll upload it. Uh, and unfortunately, I think for OBST, I don't have recorded of theory, but I have recorded of program. I'll just upload the program only. So hope everyone has understood. If it's done, then we will now. So I think I'm fine to end this. Let us meet in next lecture.